Hello, welcome to the second video on implicit differentiation. We'll look at two exam type questions. The first one is going to be an easy to medium difficulty problem. And the second one is maybe medium, just medium. I was going to say medium to difficult. Let's just call it medium. My name is Nakia Rimmer. I'm happy to help you through this journey. And so let's go ahead and get started. We have a function that's described implicitly. How can you look at it and know that it's an implicitly defined function? The x's and y's are mixed in together where you can't algebraically solve for y equals a function of x. And so with that function there, we want to take its derivative and still be able to find not just the slope of the tangent line, we want the actual equation of the tangent line. You could do this. So last time we were introduced to the idea, and in that video, we looked at replacing the y with f of x. That's not something that we want to do every time. So we just take the equation as it is. We take the derivative of every single term. And when we encounter a term that has both x and y in it, we have to remember that we must use the product rule. When we encounter the derivative of a term with y, we must remember that we must use the chain rule and multiply by y prime. So the first term, d dx on x cubed. The derivative of x cubed, 3x squared. Second term, d dx on 2y squared. The derivative of 2y squared is 4y, but you just took the derivative of a term with y, chain rule, multiply by y prime. You don't have to do that with x, but you need to do that with y. Y is some function of x, which we can't express, so we have to multiply by y prime from the chain rule. Okay, great. Then we move to this third term on the left-hand side, and it has x and y both in it. So we treat it like a product rule. We take 3x as the first term, y as the second term, and what we get then is derivative of the first, 3, times the second, y, plus the first, 3x, times the derivative of the second, which is y prime. And I'm color coding the y primes on purpose because I want them to stand out so I can find out where they are. My goal is going to be able to eventually solve for that. On the right-hand side, derivative of 6, any constant, has a derivative of 0. The rate at which it changes is 0. It's not changing at all. So this is how you should do the problem. You get it done quickly. At this point, in the last problem we did, we kind of solved for the formula y prime. But it's not generally how you do it, though. What you should do is just plug in a number. Somebody gives you both an x and a y. Just plug that in. It's easy to deal with the numbers than actually the formulas. So we're going to put the x in as 1, put the y also in as 1, and we'll have 3 plus 4y prime plus 3 plus 3y prime. So 7y prime is a negative 6. That's it. Y prime is negative 6/7. And actually looking at these answers, we can definitely see why the answer is D. But let's go ahead and get the slope of the, let's go ahead and get the equation of the tangent line by taking this slope and that point and plugging it into a generic y equals mx plus b and finding out what b is. The slope is negative 6/7. The x and y are both 1. So 1 equals negative 6/7 plus b. Add over 6/7. 1, which is 7/7 plus 6/7, 13/7. So your equation is definitely D. Not bad at all. Easy. Medium. Easy, medium. Easy. Okay, let's take a look at the next question. Find 2 points, x and y, where the curve given by that expression has a horizontal tangent line. Okay, so there's the graph. It is an ellipse that's been oblique ellipse. It's been shifted and rotated, and it's our job to be able to find these 2 points, x and y, coordinates for the points that give us a horizontal tangent line. Okay, so we take this equation, take the derivative of the equation, and look at each term. So the derivative of x squared is just 2x. The middle term, it has x and y in it, so we're going to have to do a product rule there. Third term has just a y in it, so we'll take its derivative, but we'll remember the y prime, and the other side of the equals, that's just going to be 0. So we have 2x, and then we have a product rule. Derivative of the first, x is the first function and y is the second function. Derivative of the x is a 1 times the y plus the x times the derivative of y, written once again as y prime in a different color so it stands out. And then y squared derivative is 2y, y prime, and then it's equal to 0. We don't know the x and y to plug in here. So we're just going to have to go for the formula. Any term that doesn't have y prime, ship it over to the other side. Any term that does, keep it and factor it out. So we'll subtract the 2x over, subtract the y over, factor out the y prime from the 2 remaining terms, and then divide by that. This is an expression for the derivative at any point that's along this curve. We're interested in the 2 points that have horizontal tangent. What does that mean, horizontal tangent line? So the horizontal line, first off, has what kind of slope? 0 slope. Okay, tangent has what kind of slope? The derivative. So therefore the derivative must be 0. All right, great. You have the derivative in hand. Set it equal to 0. Multiply by the denominator. And you'll have the following expression, negative 2x minus y is equal to 0. Or y is negative 2x. So what's going on here? Well, there's a line. Y equals negative 2x. And our 2 points will intersect that line. On top of being places where you have horizontal tangent line, they also have to occur when this is true, when y is equal to negative 2x. What are we going to do with this? Find the intersection between y equals negative 2x and our curve. Replace all the y's with negative 2x in our curve. We'll have an equation just in x, and we can solve. We'll have x squared minus 2x squared plus 4x squared. Oh, that's convenient. Is equal to 3. When you add those all together, you get 3x squared equal to 3. So definitely x squared is 1. So on the one hand, x could be 1. And then we'd plug that into the equation y equals negative 2x. That's the easiest thing to do. And we'll get the y must be negative 2. So there's your first point. 1, negative 2. But don't forget though, x could also be negative 1. And therefore y would be positive 2. And you did it. You solved the problem. Medium. Medium, maybe a little bit difficult. Not much. This ends the lesson on implicit differentiation. We're going to use this now in many other areas. And so please remember it. And thank you for watching. My name is Nakia Rimmer. I'm happy to help you through this journey. Please like and subscribe. Comment down below. And if you want extra resources, please don't be afraid. Find your way to my website, and I have a lot of extra educational resources to help you make it through your course. I'll see you in the next video.